Algorithm and flowchart. In our daily life, we receive some commands and give instructions to execute any work. The work could be as simple as getting up early in the morning or switching on a computer system. We only work as per instructions and commands given to us. Likewise, when your mother asks you to bring vegetables from the market, does she simply ask you to bring the vegetables or gives you detailed step-by-step instructions, something similar to this? Take money from the purse, open the door, go to the market, look for your required vegetables, purchase it as needed, come back home. It would always be easier to find anything when detailed instructions are given. Giving detailed set of instructions is always important because it enables you to have clear understanding of what, motive, how, process, problems, interventions. Let us take an example. Suppose you have to buy a pack of pencils from a local stationery shop. Here are the instructions. Step 1. Go to the stationery shop. Step 2. Ask for pencils. Step 3. If pencils are available, take that and make payment for the same. Step 4. If not available, then check any other stationery shop. Step 5. Return home. Algorithm. The detailed step-by-step instructions to perform a task is commonly known as the algorithm. The algorithm can be popularly written for the motive of performing a task along with its objective and all the possible scenarios. Characteristics of a good algorithm. A good algorithm must have the following characteristics. Input. An algorithm receives an input. Generality. An algorithm works on a set of inputs. Clear. It must be unambiguous. Each of its steps must be clear, precise, and well defined. Easy and simple to understand. An algorithm is written using simple English-like language. A person without having any prior knowledge of programming can easily read and understand the steps in an algorithm. The finite number of steps. An algorithm must have a finite number of steps to solve any problem. It must terminate at some point. Output. After processing the input data, it must be capable to produce the desired result. Need for algorithm. You are aware that the computer works smartly, but it is not able to do any work on its own. Computer needs instructions for carrying out any task. To perform every task on the computer, you need to give well-defined step-by-step instructions to it. You must also consider all the possible situations or problems that might come up during the execution of the task. Algorithms are written in simple English language. With the help of algorithms, you can easily create detailed instructions. Before developing a software, its algorithm must be developed. So, algorithms help the computer programmers in making a list of instructions that is given to the computer to perform any task. Rules for writing an algorithm. An algorithm must be written in an English-like language. The language must be simple and easy to understand. It must have a precisely defined input. Each step must be referred by a unique number and written in a sequential manner. An algorithm should not include any computer code. It must have a well-defined starting and ending point. One can define variables and mathematical expressions to calculate result. An algorithm must perform some actions to produce expected output. Symbols used in an algorithm. There are some symbols or operators that are used while writing mathematical algorithm. For example, this means z will have a value of the sum x plus y. Symbols used in mathematical algorithm. Symbol, operation, addition, subtraction, multiplication, division, assignment. It is equivalent to, equal to. Examples of algorithms. Example 1. Write an algorithm to prepare a cup of tea. Step 1. Put a tea bag in a cup. Step 2. Fill the kettle with water. Step 3. Boil the water in the kettle. Step 4. Pour some of the boiled water into the cup. Step 5. Add milk to the cup. Step 6. Add sugar to the cup. Step 7. Stir the tea. Step 8. Drink the hot cup of tea. Example 2. Write an algorithm to purchase a t-shirt up to Rs 250 from a garment store. Step 1. Get money from the parent. Step 2. Go to a nearby garment store. Step 3. Ask for the t-shirt of your size. Step 4. If you liked the t-shirt, then ask for the price. Step 5. If the price is less than or equal to 250, go to Step 6. Else, go to Step 8. Step 6. Give money. Step 7. Collect the t-shirt. Step 8. Go back home. Although real-life examples are good to understand how an algorithm works, algorithms find the most common uses in solving mathematical and computer problems. In terms of computers, algorithms are also defined as a step-by-step procedure to solve a problem. Example 3. Write an algorithm to input the username and say hello. Step 1. Start. Step 2. Ask for the name. Step 3. Save name in variable n. Step 4. Display hello n. Step 5. Stop. Let us learn some more complex examples of the algorithm. Example 4. Write an algorithm to check the greater number. Step 1. Start. Step 2. Enter two numbers, number 1 and number 2. Step 3. Check if number 1 is greater than number 2. Go to Step 4, else go to Step 5. Step 4. Display num1 is greater and go to Step 6. Step 5. Display num2 is greater and go to Step 6. Step 6. Stop. Let us now complicate the same algorithm a little more by introducing a third number. Example 5. Write an algorithm to enter three numbers and then print the greatest number among the three. Step 1. Start. Step 2. Enter three numbers, num1, num2 and num3. Step 3. Check if num1 is greater than num2. Go to Step 4, else go to Step 6. Step 4. Check if num1 is greater than num3. Go to Step 5, else go to Step 6. Step 5. Display num1 is the greatest and go to Step 9. Step 6. Check if num2 is greater than num3. Go to Step 7, else go to Step 8. Step 7. Display num2 is the greatest and go to Step 9. Step 8. Display num3 is the greatest and go to Step 9. Step 9. Stop. These steps are a bit more complicated. Imagine the difficulty of reading even bigger problems. There is an easier form of depicting the same step-by-step procedure graphically in the form of flowcharts. Let us now learn what flowcharts are. Flowcharts. A flowchart is a diagrammatic representation of a sequence of logical steps of an algorithm. Flowcharts are proved quite helpful when it comes to analyze the logic of a program. Like algorithms, flowcharts are also created using the step-by-step instructions written in English language. Each instruction is displayed within a geometrical shape. The general direction of program flow in a flowchart is either from top to bottom or left to right. Let us now learn some shapes which are used to draw flowcharts. Flowchart symbols. This table displays the most commonly used flowchart symbols. Symbol, name, use. Start-stop box. It is used to mark the beginning and ending of the flowchart. Input-output box. This symbol is used for accepting input and giving output of a program. Processing box. This box is used for writing the processing instructions and performing calculations. Decision or condition box. This symbol is used for checking or applying any condition in a program. Flow lines. These flow lines show the direction in which the control of the program moves. These lines are also used to connect the different geometrical symbols in a flowchart. On-page connectors. These are used to connect one part of a flowchart to another. Basic flowchart rules. A flowchart must have a start and a stop symbol. It must have short, clear, and readable statements written inside the symbols. It is considered a good practice to create a flowchart that fits on a single page. In a flowchart structure, the general direction of flow must be from top to bottom or from left to right. It helps the readers to easily read and comprehend the information. The flow lines must not cross each other. Use geometrical symbols correctly as per their functions. Let us now create the flowcharts for the algorithms written earlier. Flowchart 1. Draw a flowchart to prepare a cup of tea. Start. Take a saucepan, tea bag, water, sugar. Put the tea bag in a cup. Fill the saucepan with water. Turn on the gas. Let the water come to boil. Turn off the gas. Put some boiled water into the cup. Let the tea bag brew for a couple of minutes. Add some sugar to the cup and stir it well. A hot cup of tea is ready to sip. Stop. Flowchart 2. Make a flowchart to input username and say hello. Start. Take name from user. Save X name in variable. Message hello X. Stop. Flowchart 3. Make a flowchart to enter two numbers and then tell which one is the greater number. Start. Enter num1 and num2. Is num1 greater than num2? No. Display num2 is greater. Yes. Display num1 is greater. Stop. Advantages and disadvantages of a flowchart. A flowchart too has its pros and cons. Let us have a quick look at some of its advantages and disadvantages. Advantages of a flowchart. A flowchart offers visual clarity since the readers can understand the flow and progress of a program in a glance. A flowchart works as an effective communication tool, for it is a diagrammatic representation of a program. It helps a programmer to explain the logic of a program easily. A flowchart plays a vital role in writing programs. Once a flowchart is prepared, the programmers could use it as a roadmap to write the concerned program. The maintenance of operational programs becomes convenient with the help of flowcharts. Disadvantages of a flowchart. It is a time-consuming technique since drawing and redrawing symbols could be a laborious task. Showing branching and looping in a flowchart could be an uphill task, especially when a designer needs to change any logic in a flowchart. It usually requires a completely new flowchart. A flowchart is only a visualization of a program. Hence, it does not function as an actual program. Programming practice. Program 1. Write an algorithm and draw a flowchart to input a number and check whether it is an even or an odd number. Algorithm. Step 1. Start. Step 2. Read the input value for num. Step 3. Check if num2 equals to 0. Step 4. If the entered value is even, then print this is an even number. Else print this is an odd number. Step 5. Stop. Start. Read num. Is num2 equals to 0? No. Display this is an odd number. Yes. Display this is an even number. Stop. Program 2. Write an algorithm and draw a flowchart to find the area of a rectangle. Algorithm. Step 1. Start. Step 2. Read the input values and store them in L length and B breadth variables. Step 3. Calculate the area L into B of a rectangle and store the result into a variable named area. Step 4. Print the value of area. Step 5. Stop. Start. Read L, B. Area equals to L into B. Print area. Stop.